Masonry is currently incorporated in BIM software in a very limited way. This is why we have the BIM for Masonry project. We want architects, engineers, general contractors, subcontractors, and building owners to look to Masonry for building solutions. And in order to do that, there needs to be a robust Masonry tool system built and developed and incorporated into BIM software. Clash detection. Build it before you build it. It's building the building virtually before you actually build the building. In this way, you can minimize conflicts that would normally occur in the field. For example, having a structural cross bracing go through an open doorway. You can easily see that in a three-dimensional BIM model, and so you can offset that and make the change before it actually really happens in the real world, saving time and money. Improved cost estimating. Contractors are learning how to monetize with BIM. The models know what quantities are in the models. So the contractors can use those quantities and apply their cost to achieve a more accurate cost estimate. Communications. BIM changes the way we communicate. BIM allows new opportunities for subcontractors to communicate with the design team, so that includes architects and engineers, and also with the general contractor. By being involved early on a project, a subcontractor can actually help influence the design of the project. Fewer RFIs and change orders. We talked a little bit about clash detection before, and that's finding those problems before they exist in the field. It reduces the amount of requests for informations, those are the RFIs, to the architects, and it also reduces the amount of change orders to the contractors and the subcontractors, reducing the cost to the owner and to the general contractor. 4D and 5D. Let's back it up just a step. We know what 2D and 3D is. Everybody understands that. 4D is simply taking 3D and adding the element of time to the three-dimensional model. So it's really adding a schedule to it. So taking a BIM model and attaching a construction schedule to it and placing a time on an event on a specific item in the model, you can sequence the construction of the model. And for 5D is really adding the element of cost to that model. So 4D is time, 5D is cost. And so adding the cost to the model, now we're getting back to estimating and quantity takeoffs and creating more accurate bids on the projects. Well, as we mentioned before, there are limitations in the current BIM software when it comes to masonry. One of the limitations is what we call level of development. Level of development is called level 100, 200, 300, 400, and level 100 is very simple, level 400 is very detailed. And right now, most of the BIM software for masonry is at level 100, so things are very nondescript and it's hard to read what's going on. For example, architects, when they cut a section through a building, they really can't see the coursing through the wall or the bonding pattern on the exterior of the wall. They have to apply a hatch to the wall to get the bonding pattern to appear, and they have to draw two-dimensional lines to get the coursing to appear through the wall section. The future of BIM for masonry is a very positive one because it comes from a very limited background. Really, the sky's the limit. The goal is to raise the performance level of the BIM software and also the designers, the architects, engineers, contractors, subcontractors, and owners, into keeping masonry relevant in a changing industry.